Yes, welcome to our online class. Today we shall derive the EMF, electromotive force equation of a synchronous machine. So, to start with, what's a synchronous machine? We know that a synchronous machine is a machine. It's a machine in which alternating current flows in the armature. Winding. And DC, that's a direct current, excitation is supplied to the field winding. So we say synchronous machine is a machine in which alternating current flows in the armature winding and a direct current excitation is supplied to the field winding. So we can also say that a synchronous machine is a machine whose synchronous speed is directly proportional to its frequency, or to the frequency under steady state conditions. Now, we said a synchronous machine is a machine whose synchronous speed is directly proportional to the frequency under steady state conditions. What are we saying here? It means that the synchronous speed is, if I say synchronous speed is directly proportional, okay, let me just write the full formula, is 120 multiplied by frequency over number of poles. You can see the synchronous speed because this is at an angle of 120 degrees. So synchronous speed equals to 120 times frequency divided by the pole, where Ns represent our synchronous speed, our F represent the frequency, and our P represents the number of poles. Now, we want to derive the EMF equation of this synchronous machine. The first thing you have to remember is that the average EMF, E average, is the flux multiplied by the synchronous speed multiplied by the number of pole divided by 60. Because this is revolution per minute. So to convert revolution per second, you divide by 60. Now we are going to derive the root mean squared EMF per phase. So root mean squared EMF per phase Don't forget, this is root mean square EMF for the phase. Is always what? You know your root mean square value is always your form factor multiplied by the what? Average EMF. And you know that form factor is always equal to what? 1.11. So it means that I am going to have 1.11 multiplied by what? E average. Very good. Now my E average is 5 multiplied by synchronous speed multiplied by pole over 60. So I will have 1.11 multiplied by what? 5 multiplied by what? This over 60. Now, my n, the synchronous speed, we derive that it is 120 times frequency over pole. So I'm going to substitute this here. So I'm going to have 1.11 multiplied by this, multiplied by, my n here is 120 times frequency. Now let me include this p divided by 60 multiplied by the pole from here. So from here, this we cancel this. This we divide this, so I have 1, I have 2. So here, my EPH equal to 2 times 1.11. So I'm going to have 2.22 F of this. Now, for let's say Z number of conductors, my root mean square voltage EMF per phase equals, I'm going to multiply with this, 2.22 this times Z. Now we are going to consider our distribution factor KD. This is distribution factor, and our KC, which is what? Coil span factor, right? So I'm going to multiply them with this, so that our root mean square per phase is given as 2.22. So if I multiply with this, I'm going to have KD distribution factor multiplied by coil span factor multiplied by frequency multiplied by the flux per pole multiplied by the Z number of conductors. Now you know that your Z, the conductor, we have 2 turns. So it means, let me say Z equals 2T. So I'm going to substitute 2T for Z here. Then I'm going to multiply this equation by 2T. So that root mean square per phase is going to give me 2.22. If I bring these 2 here, 2T here, 2 times 2.22 will give me what? 4.44. Then multiply by distribution factor, multiplied by the coil span factor, multiplied by the frequency, multiplied by flux. Remember, Z is now 2T, and 2 have multiplied this, multiplied by T. And this is the EMF equation for a synchronous machine. So remember, a synchronous machine is a machine whose synchronous speed is directly proportional to the frequency. So you get the average speed, which is always the flux multiplied by the speed multiplied by the number of poles divided by 60. Then your form factor multiply your average EMF, and form factor is always 1.11. Then you do your substitution, you remember your distribution factor, your coil span factor, and if you are considering the terms, you know that your Z equals to 2T. By the time you start this into this equation, you have derived the EMF equation for a synchronous machine. Thank you very much. Remember, the deal is that you must be happy, I must be happy, we must be happy. So do so well to subscribe, comment, like, and share.